personally recommend Java because it will clear off a lot of fundamentals. Plus, you have a whole lot of knowledge and material available on Java. But let's assume you have zero knowledge of computer science. Where do you start from? A rough framework. It is upon you to execute this. You might decide to take a course. You might decide to learn it on your own. You might decide to go YouTube and all of that. Hello girls and boys, how's it going? So one of the most frequent questions that I get asked is, how do I get started with DevOps? Now, whether you are from a IT background or an IT background, this is a question that comes up very often. Another variation of this question is, hey, I want to upskill myself in Docker, Kubernetes, cloud. How do I go about doing it? So in this video, I will talk to you about the thought process on how to upskill yourself. If you're a fresher, this video is a definite watch. Clear up a lot of the confusions in your mind. If you have a couple of years experience and either want to switch into DevOps or you want to upskill yourself, this is a definite watch. If you already have about 10 odd year plus experience, this is a good video to watch because at the end, I will give you some framework, a methodology on how to keep yourself updated with all of this stuff that is going around in the world today. So watch till the end and I'm sure each one of you will get something to learn and it's a fun watch as well. Now if you're new here, my name is Savinder Puri and I have been in the DevOps, software engineering, cloud space for 20 plus years. I've had the opportunity to work in India, UK, Europe and the US. You can check out my LinkedIn profile to know more about my credentials. So strap on your seatbelts and let's get started. Two approaches to learning. Now, whenever you want to learn something, the traditional way of learning is to first get a syllabus of what you want to learn. You know, the entire laundry list of things. And then you go chapter 1, chapter 2, chapter 3, and so on and so forth. And along the way, you do some practical work as well, so that you actually put into practice of what you're learning. This is how we have learned in school, in college. This is how we have learned so far. Now, there are a couple of problems in this style of learning when applied to software engineering. Number one, it's too slow and it's too intimidating. Because when you look at DevOps as a topic and you make a table of content, it is going to be a pretty long table of contents. Number two, as you start learning, even though you're learning things theoretically, you have nothing to show on what I have learned in the last 1 month. And that's not a good situation because it starts working on your psyche and lowers down your self-esteem. You also get the feeling of getting lost in all of this. And typically what happens is, you started learning Linux, you read something of the cloud, you start reading about the cloud. Then you learn something about serverless, you start reading about serverless. Then you learn something about networking, you start learning about networking. And it's a rabbit hole. It goes on and on and on. After 1 hour, 1 day, 1 week, you get the feeling, what the heck am I doing? Am I even learning anything? So don't take this approach. Instead, try this new approach that I'm going to talk about now. What you first do is you figure out a problem statement, right? What's a problem statement? What do I want to solve? What do I want to work on? Then start to implement that straight away. Now, obviously, when you start to implement something, you don't know how to do it. So break down that problem statement. Look at one thing to solve, read about it, learn about it, go implement. Pick up the next thing to do. You don't know how to do it? Great. Read up on that, watch a video on that, read a blog on that, implement. Once you've done something, add more complexity to it. Of course, you won't know how to do it. Then go back, read about it, implement. So effectively, what you're doing is you are learning by doing. And you do that long enough and you will realize that you have a lot to show. It'll increase your confidence and you'll be able to answer practical questions in interview. Things like, what problems did you have? How did you debug it? How do you do this? How do you do that? You'll be able to tackle that as well. All right. Now enough of the Gyan theory. Let's deep dive into it. Let me get my iPad out and I will start scribbling. First, let's assume that you're a fresher, whether IT, whether non-IT doesn't matter, But let's assume you have zero knowledge of computer science, or very little knowledge. Where do you start from? Let's call this the prerequisites, because you need this to be able to even start thinking about knowing DevOps. What does that do? First, watch a couple of videos on what does a DevOps engineer do. Put that on YouTube, see what they're talking about. Watch 10-15 of them, you will get a general sense of what we are talking about. Then dive straight into operating systems. Pick up Windows and pick up one flavor of Unix. Now for this, you might want to buy a course from Udemy or any of those platforms, but finish that course in 2 weeks, because the goal is for you to learn an operating system. Now, assuming that you already know Windows, because your primary laptop is Windows, read about a little bit about internals of Windows, the networking, how it is done, those kind of things. And when you come towards Unix, start with an editor. Download Vim editor, VIM, and start typing something on Vim. You won't be able to type even a single character. Learn that. Learn typing in Vim. It is a superpower for a DevOps engineer, right? So Unix, Windows, pick up a small course, finish it off in 2 weeks, and Vim editor. Then next you go to shell scripting. So learn the basics of shell scripting. Also do this in 2 to 3 weeks, right? You're not writing fancy ass programs in shell scripting. Just learn how to do basic stuff in shell scripting, and then I'll come forward to it. So learn a little bit about file systems, how to manipulate files, how to do regular expression. Any good course in shell scripting will teach all of this. Again, 2 to 3 weeks, and I'm assuming you're doing all of this full time, right? Otherwise, adjust the timing appropriately. Okay, so you've done operating system, you've done shell scripting. Now pick up a programming language. And I would recommend either Java or Golang. If you want to go the basics of good programming language, it's wise to spend a couple of weeks learning Java. If you want to go fast track, maybe Golang is also good enough. But I would personally recommend Java because it will clear off a lot of fundamentals. Plus, you have a whole lot of knowledge and material available on Java. Golang also exists, but it needs a little bit of experience to do that. So my take, Java, you can go with Golang as well. And then look up Python. But you can do Python a little bit later. Even if you just focus on Java for now, that's okay. Now, what do you need to learn in Java? Look at the basic syntax, look at object-oriented, write some programs, and ultimately you want to be able to write a full-blown web app which can be deployed on a Tomcat server. That's where the level that you want to get at. Even if it is 2 lines, 2 tables in a database with a web page, that's good enough. Should take you about 3, 4, 5 weeks to do that. Okay, so that covers the prerequisite: operating system, shell scripting, programming language, and yes, then after that, go to Git. Understand how Git functions, what is source control, distributed source control, create an account on GitHub, do some checkout, check-in, put some code there, the Java code that you've written, put it there, see how it works. That will complete the prerequisite. Now let's go to the next section, which is SDLC, Software Development Lifecycle. Now read a little bit about what is SDLC, what does it do, what are the various phases of SDLC, and so on and so forth. After you've read that, then what you do is, I'm assuming you've already built a web app in Java by now. You know that by now. So go to GitHub, create an account for yourself in GitHub, and check in this code for a web app in the GitHub. Then on your local laptop, you download this code and create a WAR file. Next step, you set up Tomcat web server on your laptop itself and deploy this WAR file on Tomcat. Now, if you've done the previous prerequisite, all of this you should be able to do in less than a day if you haven't already done it, because it's a prerequisite. So this is creation of code manually setting up of a build, creation of a build, and manual deployment. Now it's time to get into the DevOpsy areas. It's time to get interesting. So what we do is set up automation now. So what you do is, on your laptop, on your machine, set up Jenkins. How do you do that? read about it. Once you set up Jenkins, then what you do is get in the Jenkins, create a project to get the code from GitHub and create a build. Once you have the war file, then deploy it on the Tomcat that you already have. Once you're able to do this, then you should have a seamless automation where you do a check-in. Jenkins should automatically detect that there is a check-in happened, create a war file, deploy that war file on Tomcat. That's one automation cycle accomplished. Good job. You've started learning DevOps seriously. Now what do? You create another Tomcat instance, run it on a different port, figure out how to do that. Once you've done that, then what you do is call the first Tomcat as dev environment, call the second Tomcat as QA environment, and then again check in code, create build, deploy to dev, then fire off another Jenkins project, deploy to QA. Now you have the beginnings of an enterprise getting formed here. Now what you do is put a stage gate between dev and QA, which means a dev manager has to log in Jenkins and say I approve, and only then the deployment to QA will happen. How do you do this? Go figure out in Jenkins. Once you've done that, now it's time to complicate this stuff. What do? You write a simple JUnit test case within the code. One simple JUnit. Write that, check it in GitHub, then set up the JUnit plugin in Jenkins. Run that. So not only is your build getting created now, your JUnit tests are also running. Once you achieve that, complicate even more. Set up SonarQube on your laptop. What's SonarQube? Static code analysis. Once you set up SonarQube on your laptop, then you integrate SonarQube as part of your Jenkins pipeline. So your build happens, your JUnit test happens, your SonarQube happens. How do you learn all of this? Simple. How do I install SonarQube on Windows? Google search, get it, set it up. How do I integrate SonarQube with Jenkins? Google search, get it, set it up. Now that you've done this, congratulations, you have successfully simulated a basic level of enterprise environment on your laptop. Next step, take all of this to the cloud. How do you do that? Maybe start with one cloud, probably AWS. Easy to start with. So go to AWS, and the replacement of your laptop on AWS, the machine is called EC2. It's an EC2 instance. Read up a little bit about AWS, spend not more than 2-3 hours, learn how to create an EC2 instance on AWS. Once you have an instance, create another one. So you have one instance for your Jenkins, one instance for Tomcat. Do whatever you have done here, replicate it on the cloud. Now you have Jenkins on the cloud, now you have Tomcat on the cloud. Now, instead of using SonarQube locally installed, use SonarQube Cloud. Integrate that with Jenkins, and you have a cloud setup. Make sense? This is still not full cloud yet. This is step 3. Now let's go to step 4, which is cloud native. What does that mean? Instead of having to set up Jenkins manually on an EC2 instance, AWS already offers you these utilities natively, which is code commit, code pipeline, code deploy. Use these 3 and simulate this entire environment. Have your code in GitHub. Use code commit, code pipeline, code deploy to deploy your code into Tomcat. You don't need Jenkins here because these guys are the replacement of Jenkins. Once you do this, you have successfully completed DevOps Cloud Native for AWS. What's the next step? Let's talk about infrastructure as code. So far, we've been building infrastructure on the cloud in AWS by hand. Now you want to automate that process. How do you do that? You learn what is Ansible or Terraform, one of these. And then what do? You replicate this setup in Terraform. So you set up an EC2 instance through Terraform and you install Jenkins in that. You set up another EC2 instance in Terraform and you set up Tomcat in that. That's the job of Ansible or Tomcat. Spin up instance, set up stuff in that. Obviously, as part of this, you'll have to do networking and all of that, but go figure that out. Step 5 is infrastructure as code. Step 6, containers. Now, all of this is running in physical or EC2 instances. Now, time to put this in containers. Learn what is Docker container, create some Docker instances, and see how you can install Jenkins in a Docker container. How do you install Tomcat in a Docker container? You can do this on your machine itself, on your laptop itself. That's fine. Do that here, right? So that's a replacement of your entire pipeline in Docker containers. Next step, take this containerization to the cloud. What do I mean by that? Use EKS, Elastic Kubernetes Service, which is Kubernetes in AWS on the cloud. Configure all of them as a Kubernetes cluster. So if you can do all of this, it'll take you about 6, 7 to 8 months to do that non-stop. But I can guarantee you, if you can complete each of these topics that I've listed here, you will be able to crack an entry to a mid-level DevOps engineer's job easily. That I can guarantee you, but you have to complete all of the assignments that I've given you. How do you overcome some of the issues that you will encounter? So one of the issues that you will encounter is, hey, you told me to set up Jenkins. I tried, it doesn't work. What do I do now? Well, girls and boys, that's exactly the job of a DevOps engineer, which is go figure it out. I know I'm not giving you easy answers. I'm not saying do this course or do that course by that person. You can use any of those to complete the assignments that I'm giving you. But what I am training you for is to use your brain to debug issues and to learn on the fly. If you learn that skill, I can promise you, you're already in the top 20% DevOps engineers out there. And I've seen a lot of DevOps engineers over the years. Learn this skill. It is worth investing the next 8 months, 9 months, 1 year in this. And as you do this, you do learn in public. What do I mean by learn in public? I've just put out a video detailed about that on how you do it. I will put the link in the description. But basically what you do is that Monday you say, hey, I'm going to be learning, let's say shell scripting in the next 3 weeks. Monday to Thursday, you learn about shell scripting. Then whatever 5 scripts you have written, you put them up in GitHub. You write a blog saying, I wrote these scripts. These were the issues that I encountered. This is how I fixed those issues. And then on Friday, you put a post saying, here is how you learn shell scripting. I got these issues. My code is in GitHub. These issues are listed in a blog post on hashnode.io. And then you go to the next topic and repeat. That's basically learn in public, but go watch the detailed video that I've put here as well. So you learn in public and you follow this curriculum that I've given you. Ballpark, it should take you somewhere between 6, 7, 8 to 9 months to complete all of this stuff. Each of the chapters that I've given you is between 3 to 4 weeks. What do you do once you've completed all of this? If you survive completing all of this, then go to DevOps periodic table. Search DevOps periodic table by Zebia Labs or by Atomic company, and you'll get that. And in that periodic table, you will see all the tools, popular tools in DevOps organized by categories. You pick each category and you make sure you know at least 1 or 2 things in that category. You should already have covered quite a lot, but I've not spoken about a lot of things yet. I've not spoken about monitoring. I've not spoken about a lot of things. So make sure for each category, you know at least 1 or 2 tools. Even in CI/CD, I've just spoken Jenkins and AWS native. We've not covered a lot of stuff here. So read about that as well. Now let's come to another very important thing. How the heck do I keep myself updated with everything that is going on out there? It's tough. I will give you a framework for that. And I've spoken about this in the past as well. I like to call it Knowledge Skill Mastery Framework, KSM. What is that? Let's say there are 100 things to know out there. You cannot know all 100. It is not humanly possible. So what you do is, out of those 100, you pick up the 10 that apply to you. For those 100, you just know what these are about. So what is Devin? What is AI? What is OpenAI? What is Sora? High level, you should know all of this about. but then pick up 10 things that are relevant to you, that are aligned with where your organization is going, that are of personal interest to you. The first one is knowledge. Out of these 10, study them in a bit more detail, study things about them. For example, I am personally interested in small language models. I'm setting up one on my laptop. I've already configured that. So that's of interest to me. That is skill development. Knowledge of 100, skill of 10, mastery in 1 or 2. KSM. That's how you approach anything. When you learn of something new, think, is this knowledge for me? Is this skill for me? Is this mastery for me? Mastery cannot be more than 1 or 2 because that's mastery. So using this framework, you can figure out this new thing that you're curious about, which level does it fit in, and put an effort basis of that. Hope this video made sense and hope you were able to clear out some confusions going on in your mind. Now, while I've given you a rough framework, it is upon you to execute this. You might decide to take a course, you might decide to learn it on your own, you might decide to go YouTube and all of that. That is up to you. But I can promise you, if you complete this syllabus, you will clear DevOps interviews. There is no questions about that. Let me know in the comments what do you think about it, and I'll see you in the next one.